I'm going to continue where I left. I showed you how to do a constraint system, a closed loop system using MATLAB derived equations, simulated it. I'm going to show you how to do it with CoppeliaSim. It's a lot simpler than doing it in MATLAB because you don't see the equations. Okay, so I'm planning to do a 10 link pendulum as opposed to a 5 link. And the key thing here is that we basically will model a pendulum, okay, a 10 link pendulum first. And then we'll use what is known as a dummies, which is a part of, which is one of the things in CoppeliaSim, which I've not yet talked about, to create what is known as a dynamics overlap constraint. Okay, and I'll show you how that goes. Basically, you make the pendulum from one hinge point, and then you keep the other end free, and then you sort of tell CoppeliaSim that that point is actually constrained to a hinge joint over here, and then it basically does its own computation to ensure that that loop is loop constraints are satisfied, and it will do the simulation. Okay, so let's get started. Okay, so first I'm going to create a stand, but that stand which you have done for the pendulum example is not going to be fixed to the floor. It's going to be floating in the sky, and I'll show you how to do that. So let's add a primitive shape, let's say a cuboid, and we can keep it 0.05, 0.05, 0.05. Let's see if that looks okay. That looks fine. Let's move it up. It doesn't. Okay, let's just move it in a systematic way instead of doing it randomly. So position, let's move it in the z direction. Let's say 1 meter. See how it goes. Okay, that's fine. Okay, now let's create a hinge joint and add it to the cuboid. So joint revolute, and we want to make it, well, let's rotate it first. So we want to rotate probably about the y-axis. So let's rotate orientation y-axis 90 degrees. Okay, so if you rotate it axis are this way, I think this principle no problem, but let's just rotate the other way. Let's just rotate about the x-axis 90. Yeah, that's better. Now we can see it easily without me rotating the whole thing. Let me call that joint 0, and we call this as the stand. The best way to move the joint onto the stand is to make it a child, and then click on translation, go to parent frame, and then you can see it's at -1 the parent frame. Just make it at 0, so it just line up right in the middle. I want to make it slightly bigger and shorter in length, so let me go to the properties, change that length to maybe 0.05 because that's the width of the cube, and then, oh sorry, that should be, yeah, 0.05, 0.05, I think is better. Okay, that looks good. Okay, and now I'm going to try to hang a pendulum from that pin joint. So let me create a shape. Let's call it cuboid is fine. Let's keep it at 0.05, 0.05, but for the length, now this is a big decision. So if I make it too long, then my chain is going to be very long, and then that's not going to help me out. It's a question. Is it 10 links because the ground is counted as one link? Not really. I'll actually have 10 pendulums connected end to end. 0.2. So that way, when I do 10 links, it will only be 2 meters from the floor, right? So 0.2 for the height, and that shows up. And we want it to basically line up with the pin joint. So let me just move it to the joint, and then translate with respect to the parent frame. That's important, and 0. So that lines up exactly midway. We want it to move slightly down, right? 0.1 meters down, so that it actually lines up. This is parent frame. I should have known that. So it's 0.1. I did a little bit of trial and error, or I have to figure out exactly what the axes are. That looks the opposite direction. Let me make it minus. Okay, that looks good. Uh, okay, now let me just save it before we proceed. Desktop. Let's just call it 10 link pendulum. Okay, done. Now, if I let this go, then things fall down, right? Like, because it's not anchored to the ground, and so I need to anchor the stand to the ground. So what I do is, you can go to the dynamic properties, and here you can say you want this to be static. So remove the dynamic. Now I think it will not fall. It's doing something crazy, and it's doing something crazy because what's happening here is I have what is known as I've made these things respondable. So the stand is respondable object. What it means is that if it is in contact with another object, it likes to react against it. So if you wanted to not do that, then you just change it to be not respondable. So in case contact will not be detected. Now it's all looks good. Okay, that looks good. Let us see how to move the pendulum. But before that, let me call this link one, and I need to change this to say 90 degrees. And then we let go. Okay, this is crazy fast because I need to do real time and it look better. Let me just move this. I have this. Zoom out a little bit. Okay, I'll do real time and let go. Okay, that looks like a pendulum. Nothing fancy, nothing interesting here. Let me just split back to 0. Okay, so this is the hardest part, getting that pendulum going. Now it's kind of easy because you just have to do copy paste. So copy that, paste it. It's actually overlaid on the previous one, so you can just take that, make it a child of link 1, and then all we need to do is tell this that its position is going to be, I guess, 0. Yeah, it should be minus 0.1. Oh, plus, my bad, minus 0.2. Interesting, because how did that happen? So joint one is joint one is actually should be 0.1 from the center of mass of link one. Link one center of mass is here, and so that's 0.1. So I just need it to be minus 0.1. This should work. Okay, so we have that, and let's test it out. Looks good. Let's stop. Let's move one of those links 90 degrees. Let go. Looks good. Let us change the length of the other pendulum, I mean the angle of the other pendulum, 10 degrees, say. And so this should be a double pendulum. Nothing fancy. Let me just change this to slightly different angle, 90 degrees. Okay, let's see what happens now. There seems to be a problem here. It's straightening up without, and I think that the problem is that I should make this non-respondable because there is an overlap between the links, and that is causing it to basically collide and do something crazy. Go to dynamic properties, remove the respondable. If I want to avoid this, then I better design the links such that there's no overlap. So I think this should work fine now. Yeah, it looks much better now. So this is how you want it to look. And that's how I got the animation to work in MATLAB in the first place. That looks better. Okay, we got this. Okay, now let's just go back and just change this to 0, and then the other one to 0. Okay, so now before we do anything more fancy, let's just move the stand to the place we want it to move. So we know that if you have 10 links, then it's going to be 10 times 0.2, which is 2 meters. So I need to have it at least 2 meters from the floor. Otherwise it'll, well, in this case, actually, it will not collide with the floor because I've made the system to be non-respondable. But anyway, for a pretty animation, we don't want it to go through the floor. So let's just take the stand, go to the wall frame, and then change it from 1 meter to 2.5 meters. That takes care of it being fairly higher than the ground. So if you zoom out, you see it. Great. Okay, so now we just take these four, copy, paste. Something doesn't look right to me. The way these have numbered makes me nervous. So I'm going to delete this, and I'm just going to go step by step. Take these two links, um, copy them, make them a child of that. Then click on translation, make that parent frame, that minus 0.1, and then that looks okay. And I just have to keep doing that. Okay, we are 5 links. Okay, I think I know why that links were not numbered correctly. When you click this, and I'm going to try this, it works. Hopefully it will work. So you want these two, you want to copy these 5 links and attach them to the end. And I had just randomly clicked like this, and that causes the disaster where they are numbered weirdly. If you want to select them in a certain order, you just select them in the order you want them to be named. So start with joint 0, link 1, joint 1, link 2, joint 2, link 3, joint 3, link 4, joint 5, link 5. And I believe if I now copy and paste, they'll all look fine. See 5, 6, 7. Okay, so it looks fine. Okay, now we just need to take this and move it there. And the good thing about this system now is that I just need to move one joint. So I need to just go to the 5th joint and do translate and move it minus 0.1 with the parent frame, of course. And then there you have. Okay, so this is my 10 link pendulum. The 10th link is right there. Okay, so now if you let it simulate, nothing will happen clearly. Let's just change one of the angles, the top one, to 90 degrees. Okay, and so let's see what happens. Okay, let go. Stop this and get a better view. Okay, I think it's better now. Okay, now we can let it go. Okay, so things like you can change the mass length, and I think that has an effect on how this thing actually behaves. But I'm going to stop here. Okay, so that looks right. So that's basically gets you the pendulum. Now the question is, can you create a loop constraint? And to get the loop constraint, let's say that I'll first just cut this to back to 0. Okay, it's vertically down. Okay, now what we want to do is we want to attach maybe the end of the link, this one, right over here, and so then we want to simulate it. So what I'm going to do is, and this is what you need to do, which is you need to create another stand, right, and then another joint. So let me paste that, okay, and it's right there. And let's say that we call it stand 2, and then that's going to be joint. That's right. So that's sitting right here. We wanted to move it slightly to the right, so I'm going to create translate and then move it in the world frame. You can see the world frame here along the x-axis. So I just to change it to, let's say, 5 meters. So far looks like. Just try let's try 1 to see if it's okay. There it is. Changes to say 3. little far. Let's just change it to so it's visible. Okay, and maybe I need to go slightly to the right because there's not going to be much interesting dynamics to the left. Okay, now we got that stand, we got that joint. Now the question is, how do we close the loop constraint? So here's where you need to use what is known as a dummy. Okay, I need to put a dummy at the end of link 10, and I also need to put a dummy at the stand 2, and then sorry, at the joint 10, and then I need to tell CoppeliaSim that those 2 points should connect. Okay, so let's first create a add, and the dummy is right here, and let's call that um, end of link. So let's make it EOL1, and then let's just move it all the way to, oh, I don't think we can go there. I need to do it in parts, I think. So let's just move it here first, go down, and then move it there. Okay, it looks good. It's sitting right here. If you can see EOL, if you want to make it look bigger, then you can change the size. You can make it 0.2, then it looks big, too big, 0.05. You can change its color. I never really talked about colors, but you can change the colors. So you can change it to, I don't know, if you want, say red. That looks so similar to my joints. Let me just change it to green. Okay, now what I need to do is I need to stick at the end of link 10. So I just go to translate, and then I say this should be with parent frame, it should be at, I think minus 0.1 will do it. Is that right? That looks right to me. Okay, so we got that dummy and it's attached there. Let's put another dummy exactly at joint 10. So add dummy. I'm going to just call it EOL end of link 2. Okay, and then just put it at the joint and then translate, and then say with parent frame it should be at 0, 0, 0. And then if you want to change the color, let's double click that. Let's change its size to 0.05 and just color. Let's make it, let's say blue. Okay, so that doesn't really change much, but we still need to tell it that this wraps on that. I think blue is a bad choice. Let me just change it to something else, because blue is the inside of the pin joint. So let's just change the color to something which can be seen, some light color maybe. Yeah, that's fine. Don't know, I can see it, but okay. I trust that it is there. Okay, so now I need to tell it what is known as the dynamic overlap constraint. Okay, so tell that this point, the green point dummy, connects with the I think orange color dummy too. So right click and say add. No, okay, there's no option here, but you can try. If you double click and then go, there should be a overlap constraint here, linked dummy. That's what you want to choose. Go to link dummy and say you want to link it to EOL1. Okay, and then there are types of overlaps. Okay, there is an IK, which is inverse kinematics, which we've not talked about. Hopefully we'll talk about some other time, but we want to go to the dynamic overlap constraint. Okay, because we have dynamics here. So do that, and when you do that, and if it all is looks right, then you should see that the end of link EOL2 is connected to the EOL1 through this blue line, and it actually shows you here. Okay, now I think it will not work when I click play. Oh, it does play. Okay, so that's a little bit too far. You see, there's no dynamics going on there. Let's just move this dummy slightly closer. So click on that. Oh, sorry, click on translate. I put it actually at 5 meters, which is just stupid because the pendulum is actually equal to the distance between these two, right? It's 2 meters, and this dummy is at 2 meters. So let's just change the stand to be at I don't know, put it at 1. Okay. Now wait. And so you can see that this is a constraint system, so it moves the way you would expect it to. If you want to change the way it starts off, you can then change something like, for example, I would change this to 130. Okay, so now it starts there. So then it just falls and just goes that way. Okay, nothing so much interesting here. So this is one way to do it. Okay, the other way to do it is, well, by the way, you can move this, right? You can take this and translate it and move it, say, so it's at 2.5, but you can make it at 2. Okay, and then it'll work that direction, that way too. Okay, so that's one way of uh, attaching a loop join. You could also do it the following way. Just change this back to 0 degrees. So another way of doing this is, let's move this stand to back to 2.5. Okay, this is one way of doing it. We have a 10 link pendulum, and then you attach this point, the end of the 10th link, to the stand or the joint. You could also do it the following way. You could create 5 links and the 5 link pendulum, and then you can make a 4 link pendulum and then link the last ends of 2 pendulum through a joint. So I can do that quickly, it doesn't take time. So let me first make a copy of what I have so far. See desktop. Okay, I made a copy, and I'm going to work on this new file, which is a copy. Just make this back to 0. Okay, now what I'm going to do is I'm going to basically take the fifth, so fifth, I take this maybe, so link 1, link 2, link 3, link 4, link 5. Okay, so I need to disconnect it here and move it right there. And then of course I need to tell it that, so there are 2 joints, there's going to be a problem. So I'm going to remove this, make it an orphan, make the EOL link 1. I want to actually, okay, let that just be there. I want to move this right where I want the stand to be. So I take this, I to translate. Oh, the stand is fine. I just need to change this, sorry. So this is basically end of link 5. I need to move the end of the joint 5 over here. So I click translate, and then parent frame, I want it to be exactly at the origin of the parent frame. Okay. Okay, so now what you see is this 2 pendulums, and I need to basically, I already have an end of link here. I don't have an end of link here, so I need to move the other end of link over there. But I need to move it with the joint. I need to have a joint here because this part and this part is connected through a joint. So I'm going to take this joint 10 and move it right at link 5. And then I'm going to say that since I moved, what am I doing? End of link, something is not right. Joint 10. Oh, my bad. So this was all okay. I just need to move this joint 10th right to the end of link 5. So since I made it a child of link 5, I can go to translate and then say this should be 0, 0, I think 0 will do it. So that gets it to the middle. I need to move it slightly down. 0.1. No, it should be minus 0.1. Okay, so that looks good. Okay, and you can see that it still has the connection. Okay, so it's already connected to the 2. That is, I didn't have to change the set the dynamic constraint again. So here is simulation. So it does the same thing, but now you've connected it slightly differently. So the end result is different because the connection determines the initial condition. Okay, and then you can also do things like uh, I could potentially, let me make another copy of this. If you want to make a 15 link pendulum, slightly different from what I've actually shown you, 1 second, let me show what I'm trying to do. So this is again the first system. That's 0. Okay, so what I'm going to do is essentially take this system, which is, let's say, stand 2 onwards. So copy all this. Okay, copy it, and then go here, and then I just don't want this thing. Just delete this, delete, delete. I'm going to paste it here. Okay, so I got that. I have end of link 2 now, and now what I'm going to do is I'm going to try to connect this over here. Okay, not there, but right there. So what I do is I make this as the child of, let's see, 1 2 3 4 5, end of link 5. Okay, and I of course need to tell it that it's joined to link 5, so I need to say, oh, sorry, I should make it my bad. So I should make it a child of joint 5 as opposed to link 5, because that's how I'm thinking of that. I want that link to basically connect it to the Revolut join instead of the link. So move it there and then say translate, and then say 0. It's right there. And then I need to say give an overlap constraint. So double click EOL2, overlap constraint looks fine, and then run this. What happened? Link 5. Interesting. Maybe I can't do this. Let's try linking it to link 5. Yeah, this works. Okay, so I can't give it quite that way. But here is a system where you have a closed loop chain here, and then you have a pendulum down there. So both closed loop as well as an open loop chain. And it's quite easy to do this. Closed chains are easy in this simulator if you write additional equations in MATLAB. Okay, any